A common application in physics classes is to study the motion of objects. In physics classes, the position of a certain particle or a car or something like that is usually given with a function called s of t. The velocity is the speed of that particle, and in physics, they say that the velocity of a particle, like a car or a cannonball, is called v of t, and the relationship between position and velocity is that if you take the derivative of the position function, you get the velocity. And that's what is written at the end of the line right there. The derivative of s of t, meaning s prime of t, is equal to the velocity. Similarly, the position is related to something called acceleration. So given the position function s of t, you can describe something called the acceleration of the particle, and that is usually referred to as a of t, the function. And the relationship between acceleration and position is that the acceleration is the second derivative of the position function. Another way of saying that is to say that acceleration is the first derivative of the velocity function. So all three are basically related. So if you think of it as the s of t first, if you take its derivative, you get the v of t. And if you take its derivative, you get the acceleration velocity. So doing one derivative from position gets you velocity. Doing a second derivative from velocity gets you acceleration. So the relationship from the first to the top to the bottom is the second derivative. We're going to use that knowledge to be able to do example number 7, where we are told that the position of a particle is 10t squared plus 5t plus 4. The question is to find v of t and a of t, where t is in hours and the position is described in miles. They also want us to find the distance, velocity, and acceleration when time is equal to 4. Well, let's begin by finding the velocity and the acceleration. So how do you find velocity? The answer is you take the derivative of the position, so s prime of t. Now, the derivative of 10t squared is going to be just like the derivative of 10x squared. The only difference is that we're writing the letter t instead of the letter x, so we just write down 10 times 2 times t to the power of 1. So bring the power down, then subtract 1. The derivative of 5t is just going to be simply 5, and the derivative of 4 is going to be 0. So, once this is cleaned up, this is going to be 20t plus 5. So if the position is given by that function, the velocity is given by this new function. Now what about the acceleration? How do we get acceleration? Acceleration can be obtained by doing the derivative of the velocity function. So the thing that I just circled, the 20t plus 5, find its derivative. Well, derivative of 20t is going to be 20 times 1, because the derivative of t is going to be 1, and the derivative of 5 is going to be just simply 0. So the total there is going to be just simply 20. So at this point in time, we have found the functions for the position, for the velocity, and for the acceleration. If you notice, the acceleration in this particular problem is always 20, so it's always fixed, whereas the velocity is 20t plus 5, and the position is 10t squared plus 5t plus 4. This was given to us by the problem. So once we have found the distance, velocity, and acceleration, they want us to find what they are when t is equal to 4. So basically, all we have to do at this point is plug in t equal to 4 and figure out what that answer is. So at t equals to 4, we end up with the following. S of 4 is equal to 10 times 4 squared plus 5 times 4 plus 4. So that's going to be 160 plus 20 plus 4, which is at the end 184, and position is in miles. So the unit here will be just simply miles. So 184 miles after 4 hours of travel. Whereas the velocity is going to be 20 times 4 plus 5, which is 80 plus 5, which is at the end 85. And this is velocity, so it's described in miles per hour. So this is how fast your object or your particle is moving after 4 hours. And then finally, the acceleration at 4. So after 4 hours, how much are we accelerating? Well, it's 20. And the unit for acceleration is kind of weird. It's miles per hour squared. And so that's the end of the question. Again, we don't need to know the units for this class. As long as you give me the 184, the 85, and the 20, you're basically good to go. But in physics, they care about units, so that's why it's important to mention the units.